Hey everybody, my name's Daryl Robert, and welcome to our webinar on working with the Car Configurator Sample Project. Today I have the pleasure of working with David Bayless, and we're going to be showing you a variety of things. David's going to start off by going over the look development approaches that we used for this project, and I'll be showing you how you can work with your own custom assets inside of the sample project and set things up like trigger events to open and close the doors, as well as changing the color of the vehicle. So with that said, let's go ahead and jump in there and get started. I'll hand it over to David.
Okay, so let's talk about the lighting techniques used in this project. The project is using a physically based lighting approach to mimic as close as possible to real-world physics. The scene is composed of a directional light, a skylight, a sky atmosphere, exponential height fog, and the latest volumetric cloud system as a version 4.26. Okay, so let's first start with the directional light. The sun plays a very important role for lighting, especially in this scene. And the way we approach lighting in this scene was to use physically based values. If you look at the real-world sun intensity values, the sun is measured in lux. And for bright sunlight, the values average 110,000 lux. So if we go into our directional light properties and go into the intensity, we can see that value is transposed here in lux. So by entering such a high intensity value, we will need to adjust our camera exposure to compensate for the light. So let's go to our post-process volume and let's go into our exposure settings. And we can see that we are clamping this value at the value of 14.2. Now, if I set this to 1, for example, we can see how bright that sun is and it's overexposing the scene. So we would typically go at the higher values and we can start seeing the car here. Now, if I go 12 and 12, we can start seeing that popping a bit more. And if I enter a slightly higher value of 15, let's say, we are starting to get that exposure set. Now, the way to check the color is actually via the color calibrator. So in this level, we actually included the color calibration tool for you. And this is a really good way for you to check your exposure values in the scene. Now, a good tool to use is the actual pixel inspector. So if you go into the Windows tool and go to Developer Tools and then Pixel Inspector, this will bring you a window where you can actually check the gray values. So if I place my camera actually to where the sun is hitting and check that gray value, we can see that we are hitting that 18% to 20% value of gray, which is really good. So in this scene, what we actually did was actually overexpose the scene a little bit for a more photographic look. So we entered a value of 14.2, which brightens up the scene, has that photographic look, and also helps you navigate in the configurator. Okay, so now let's move on to the skylight. And what the skylight does is actually capture the distant parts of your level and applies that to the scene as a light. So it's important to make sure that the skylight is not stuck inside the car or under the car, as it won't efficiently capture the different lighting data of your level. So a good placement is actually sitting above the car. So what we did here for the skylight was to actually increase the cube map resolution. So by default, when you drag the skylight in, it is set at a resolution of 128. So if I reset this value by clicking on that little arrow, that's going to bring it back to 128. We can actually see that we are capturing a low res of the sky here. Now, if we drive that up to 2048, we are capturing much more accurate data from the skylight. Now, what we did with the skylight here is also tweak the skylight threshold. So what the sky distance threshold represents is the distance from the skylight at which any geometry should be treated as part of the sky. So in this example, we actually went with a lower value of 200, which actually brightens a bit more the car and the side of the car. But if you want to tweak that value and let's say put it to 500 or 400, what it's going to do now is actually treat that part of the ground as a surface and not as a light anymore. So in this case, it's going to darken my side of the car slightly more. Okay, so now let's move on to the sky atmosphere. So what the sky atmosphere does here actually is giving us control on the look of our sky. So what we did here is actually change a couple of values here in the Rayleigh scattering. If we go back to default, we can see that it's much more hazy here. But if we lower this to something like 3, we get a bit more blue sky. And another interesting value here is the art direction aerial perspective view distance scale. By default, it is set to 1. And we do lose a bit of haze and depth. So we do lose a bit of depth in the background here. So if I put that back to 10, for example, we get a bit more haze and depth. We can lower this to a lower value and, you can play around with this. But it is a very nice feature that adds realism to our sky. Okay, so let's move on to another new feature that came out with 4.26, which is the volumetric cloud system, which really adds a nice touch to your sky and to your scene, especially with dynamic lighting, as I will be soon demonstrating. So if I hold Ctrl L in my viewport, and this actually allows me to control live the sun position in the scene. And we can see as soon as I start moving this, we actually see the clouds reacting dynamically to the light, and we get the nice cloud shadows going on. So as soon as you start playing with this, it's important to make sure that you are, once you have the final look, that you are building the reflection captures to update the skylight sun position. So as soon as I do that, it updates the skylight capture and gives the accurate look on that car. Okay, so let's talk about the post-process volumes. And basically what we have here is one for the exterior and one for the interior. And the difference basically come between the exposure values. So when you place your car in your scene, make sure to have that car placed inside this volume, which controls the interior exposure. So if I move my camera slightly here and slightly blend between the two here, we actually see that we are using two different exposure values for the interior and the exterior. So right now I'm in the interior, and if I go out, I'm in the exterior. And what that does basically is lighten up the interior of the car. So if I go to my post-process interior, and we can see that our min and max values here are slightly lower than what's at the exterior. So if I set that to 14.2, which is like the exterior, we don't have much light information going on. It's rather hard to see what's going on in the cabin here. So I'm going to put that back to 12 and 12. And that basically controls your exposure value for the interior. Now, another quick tip for your car scene is the emissive material. So very quickly here, I'm just going to drop a sphere, and I'm going to be applying a light material. So I'm just going to be using this guy here. So if I drop this right now, you see it's very bright because I've obviously parametered that in advance. But if I bring this value here, we can see the power is actually quite intense. So if you're used to using relatively low values between 1 to 10 and put that emissive material into the scene and it renders black, well, that is because the sun intensity is actually so high that it's occluding your emissive material. So just make sure to have a high enough intensity on your emissive material. Now, also another tip when working with Bloom is actually checking your screen percentage. So that is actually driven in the post-process volume in the runtime. So if we go into the search details and actually look at the screen percentage here, we can actually see that in runtime it's using a screen resolution of 120. So when working in the editor, it's a good practice to use that same value here. So I'm using 120 here. But let's say if I have my default screen percentage set at 100, we can actually see that Bloom reacting to my screen percentage. So if you are playing with the screen percentage in the post-process, make sure to have that same value in the editor so you can actually see the difference in the bloom intensity. Okay, so now let's talk ray tracing. So this sample project was made with the intent to demonstrate the ray tracing capabilities with automotive in Unreal. So we are using 3 ray tracing features here, which are reflections, ambient occlusion, and shadows. So we're going to start with the reflections here. So that is controlled in the post-process volume. And if we go down to the rendering features, we can see that our reflections here are set to ray traced. So if I switch back to screen space, we can actually see it does quite a decent job, but we are losing a bit of self-bounce reflection here on the rim, as well as losing a bit of definition here. So if I switch that back to ray tracing, we can see, especially in the headlights, all the metallic bounce going on here. And we're getting some really nice self-shadowing here in the wheels compared to screen space reflections. Now, the second ray tracing we use is the ray traced ambient occlusion. So that is particularly nice for your car shadows. If I turn that off, for example, we immediately lose that light occlusion going under the car. So that is a feature that is limited with screen space AO, and ray traced AO counters that and adds a nice feature. Now, the last of all is the ray trace shadows. So ray trace shadows is actually controlled with the directional lights. And what we can do here is actually play with the source angle here. So if we put a value of -4, for example, we get some soft shadows going on here, which is pretty neat. It is also useful for contact shadows inside the car, for example, or also outside. So if I play around with the light here and control L that, and let's try and get some nice shadows on the car seat, for example. And we can see here, like I can play around with the source angle, get softer shadows. I'll put that back to normal. And if I scroll down, and we can actually turn off ray traced shadows. So if I turn that off, this is using the default shadow method. That's definitely lacking some definition here. And as soon as I turn that back on, we get all that ray traced lighting information that is able to evaluate the objects in the scene in a much more accurate way. Okay, last but not least, let's talk about the console variations used in this project. So the first one I want to talk about is the reflection denoiser. So if I change the light here just slightly so we get the car in the shadowed area a bit more. And by default, when you turn on ray tracing, it's going to apply a denoiser. So we actually turn that off in the project files. But for the sake of the demo, I'm going to turn it back on. So the console command for it is r.reflections.denoiser1, and that is always turned on by default. But what it does here is actually blur the reflection samples here, and actually we're losing a lot of definition from the salt ground here. So what we did in the console commands is turn that denoiser off. So as soon as I turn it off, we get way more reflection detail going on the car paint. Now, a second one that we used is actually SSGI, which stands for Screen Space Global Illumination. And that is also enabled in the project. So right now it is turned to 1, but if we turn that to 0, for example, we see just slightly a loss of definition in the light bounce. So if I change the light here slightly, and let's turn that back on, we get a bit more light bounce going out under the car here. Now, the last console variation that we used here, which is nice to show, is the new temporal AA algorithm. So this is driven by this command called r.temporalAA algorithm. And right now it is set to 1. So if you want to switch back to the default method, that would be r.temporalAA algorithm 0. And that falls back to the normal The reason that we use that is just for sharper definition on the tire, for example, and on the dirt, it pops out a bit more. But more specifically, more interesting in the interior of the car. So if I change that back to 0, we can see that on the console here, we're losing a bit of that crispness on the text. So if I go back to 1, it's now much more clear. And it's a nice new feature of 426 that doesn't cost too much on the performance.
That's awesome, David. Thanks for that. So what I'm going to be doing is showing you how you can import in your own assets into the sample project and begin hooking them up to some of the logic that already exists in this project. So let's go ahead and jump into the configurator by clicking the play button. Now, if you guys have played around with the configurator, I'm sure you've realized there is a ton of functionality built into this sample project. So for today's presentation, we're going to focus in on a few key pieces of functionality. Primarily, we're going to be looking at how the animation system works and how it's triggered by these hotspots. All right, so here we are inside of the ID4 project that we got from VW, and what we want to do is get this vehicle added into the sample project. You'll notice that the ID4 is already added into a blueprint. So everything for the ID4 lives on this BP Export ID4 blueprint. So all we have to do is navigate to where that blueprint lives in the content browser, right-click on top of it, go to Asset Actions, Move, Migrate. So when we bring that up, it's going to give us a list of everything that's going to get migrated across. So all the materials, all the textures, all the static meshes, any logic that lives inside of that blueprint, any lights that were in that blueprint. Basically, all of this stuff is going to get migrated over to the car configurator sample project. So we'll just hit OK. It's going to basically ask, where do you want to send it? So we're going to put it in the configurator content folder, and we'll just say select folder. Now it's going to give me a pop-up saying that some stuff already exists here. They're both using the automotive material pack, so some of these are redundant. So we'll just say OK. You can see that it's copied across a bunch of files. So if we jump back into our car configurator project and we go into this cars folder, into the export folder, you can see there is the blueprint for the ID4. So all we have to do to see this is just drag and drop it into our level. Right now, the way this is set up, the ID4 has all of its geometry in one blueprint, and the Audi has all of its information in another blueprint, and that's not really what we want. Ideally, we want to get the ID4 geometry into the Audi blueprint, because that Audi blueprint has a lot of the logic for the way the car configurator works. So we don't really need the ID4 hanging out like this. We're gonna do this in a slightly different way. So we can go ahead and delete that ID4. And let's jump into the Audi blueprint and start getting it set up so that the Audi can go away and the ID4 can take over its place. All right, so let's go ahead and find that Audi blueprint by going to the content folder, going into car configurator, car blueprints. Here you can see we have the Audi A5 blueprint as well as the control rig for the Audi. These are two of the three things needed to get the animation working on the car configurator. The third being the focus point blueprint, which is the hotspots that you saw on the doors, kind of the trigger events that start the animation off. So we'll be looking at that a bit later on in the presentation. Let's go ahead and jump into that A5 blueprint and begin exploring what it does. So in the event graph is where the animation logic kind of happens. So something like a door animation is really straightforward. It's just interpolating between two different values. If you look at something like the convertible top, the logic is a bit more complicated, but it's still kind of the same idea where there's a rest state and an execution state, and it's interpolating between those two values. Now, the animation logic, even for things like the dynamic materials for the HMI, are also handled in this event graph. So you can go ahead and explore around this guy. So ultimately what happens is this animation information drives the control rig, which in turn moves a skeleton that carries these static meshes. That relationship between the static meshes and that moving skeleton is also handled and set up inside of the Audi A5 blueprint. So if we jump over to the viewport, you can see that obviously the Audi lives inside of here. There's all the static meshes. And if we look in the components on the left-hand side here, you can see that there are a bunch of fixed points for all the different hard animated areas of the vehicle. So something like the left door has parented below all that the static meshes for that Audi. So this is really great because what this means is if I want to set up the ID4, I have these nulls or these anchor points that I can just parent the ID4 static meshes underneath, and all the offsets of those local pivots is handled for me automatically. So this is really pretty awesome. You'll also notice that the control rig is inside of this blueprint, and that control rig matches, these points. These points are actually positioned by that control rig. So if we go into the control rig and just search for bone, and we display the bones of that skeleton, you can see that, they literally line up. If we grab this left front door here, you can see that that pivot point is actually exactly in the same spot as that control rig of that bone for that door. So all that information is basically being generated inside of this Audi A5 blueprint. So what we want to do is we want to hide or get rid of the static meshes for the Audi because we want to get this ID4 hooked up. So I could just take these static meshes and delete them. The problem with that is there's some dependencies inside of here. And if I start deleting that stuff, I'm just going to have to go through and troubleshoot and find all the things that got broken in the blueprint code. So instead of deleting them, what I'm going to do is I'm going to hide them. And because I want to be able to turn the Audi on and off and the ID4 on and off, instead of hiding them, in the simple way, I'm actually going to create a little bit of blueprint code that lets me make a switch to turn that on and off. And it's actually only a few nodes to do it. And I'll show it to you now. So now we're going to go ahead and we're going to tag all the Audi static meshes so that I can easily select them with a blueprint node. So I'm going to search in my details panel for tag, and I'm going to go and select everything that's below the skeletal mesh. And I'm going to deselect all my anchor points because I do not want to tag those. I only want to tag the static meshes. All right, so with that done, I'm just going to go over here and click the plus sign next to array elements. And we'll call this A5. And we'll go ahead and we'll compile the blueprint. Okay, next step is to search by right-clicking in the construction script and look for get all components by tag. We're going to set that tag name to be A5. And we're going to switch the component class to be a static mesh component. So now that we've done that, we're going to go ahead and we're just going to pull off the array and do a for each. So we're going to run through that array. And we're going to hook this up so that it executes. We're going to run through that array and we're going to set visibility on everything that's been tagged with A5. So we'll just do a set visibility and we'll grab the array element into the target. And the next step is to just promote the visibility variable. And we can give that a name that's a bit more meaningful. So we'll delete that and just call this car visibility. And let's just go ahead and drag that over here. We'll compile this. As soon as I compile it under default values, you're going to see that that car visibility is now turned off. So if we go back to the viewport, you can see that we've obviously gotten rid of most of those static meshes. If I turn this on, they're going to come back. But you'll notice that the top is still there. Those convertible tops are still there. And if we search for top, you can see that these are not actually static meshes. They're different. So what we want to do is we want to get those also have their visibility turned off. So we can just drag those out. And we'll drag out the one from the cinematic. And we'll just put those into target also. So now if we go ahead and compile this and look in our viewport, you can see that everything is hidden. Now here's the thing that's kind of cool. If we expand this down, you'll notice that in the editor, also everything is turned invisible. Now I have the Audi B5 blueprint highlighted, and you can see that a few variables are actually exposed under default, but my car visibility is not exposed. And the way if I wanted to modify that in the actual editor without having to go to the blueprint, all I have to do is turn on that eyeball to make it visible and recompile it. So as soon as I do that, you can see that it's going to show up, and I now have the ability to modify that directly inside of the editor, which is pretty cool. So let's go ahead and let's play this back. Now notice what happens when I play it back. You're going to immediately see some issues. Actually, let's stop that guy and let's turn that off and then hit play. All right, so car's not visible, but the top is. And when it comes to a rest spot here, you're going to see as soon as that UI came on, the seats popped on and the car door popped on. So what that's telling me is something is dynamically changing that visibility attribute. So what we're going to do is we're going to turn on hidden in game, which is just another node that we can add into our blueprint that will basically make sure that those guys do not display in runtime. So we'll go back to the construction script and we'll just branch off set visibility and we'll search out for hidden. And there's a couple of hidden in game. So we don't want to set actor hidden in game. We want to grab this one at the top here that just says set hidden in game. Pretty straightforward. Now, again, we need to give it the array element as a target as well as the tops. So we'll just wire those guys together. And this new hidden variable, we want to have driven from that same car visibility, but it needs to be the opposite. So that's really simple to do by dragging out and searching for not Boolean and wiring the not Boolean into that. And now if we go ahead and we compile this, and kind of shrink this guy down and hit play, you're going to see that it's going to behave the way that you would expect. So nothing's visible. We do our camera fly up. Everything looks cool. The little UI element comes on where we used to see the seats in the door panel show up, and it's all still invisible. So we've got our Audi hidden now, which is awesome. So let's go ahead and stop this from playing back. So the next thing that we want to do is we want to add into this Audi A5 blueprint the ID4 geometry so that it is now part of this same blueprint. So let's go ahead and do that. This is actually the easiest thing we're going to do probably today. All right, so this is a copy and paste operation. So we're just going to go ahead and browse and get the ID4 blueprint opened up. We'll click on this guy. So here we'll hop into the viewport and you can see there's the ID4 geometry. So what we want to do is we just want to hold down the shift key to close this down and then expand it back out to make sure all the children are exposed. And we're going to scroll to the bottom and just shift select all of these. We're going to right click to copy it. And then we can jump back over into the Audi blueprint and then again right click to paste in all that information. Now this will take a couple of seconds to process, so don't be alarmed if it takes a little bit of time. All right, cool. So we have the ID4 pasted in, and we'll just kind of zoom out here a little bit, and you'll notice that the bloom is very strong in this blueprint view, and that's because there's a couple of incandescent parts on the car, the headlights as well as the taillight. So I'll just switch this to unlit to make it a bit easier to see. And the next thing that we want to do is we want to make sure that the ID4 is positioned in the exact same space that the Audi was. So we're going to go ahead and turn that Audi back on with that switch that we built earlier. And with that done, we're going to position the root of this ID4 just forward a bit and then down a bit so that they line up with each other. Okay, so that's looking pretty good. So let's just go ahead and save this and compile it. And we're ready to go. Next, we need to export out the Audi A5 blueprint that includes the ID4 geometry as well as the skeleton to Maya to create a new skeleton that's going to match the ID4's fixed points. So go ahead and select the A5 in the outliner, zero out any transforms that might exist in the level, and then with it selected, go to File, Export Selection, to save out the FBX file. All right, so here we are in Maya with the FBX file imported, and the first thing that I'm going to do is just unparent a couple of things to make it a bit easier to work with. So we'll grab the ID4 as well as that root node for the skeleton and the mesh that's bound to that skeleton, and we'll just do a simple edit unparent. And with that done,
I can go ahead and hide the display of the Audi just so it's a little bit easier to work with. So we've got this skeleton inside of here that came across that was originally set up for the Audi, and we want to change its fixed points to match the pivot point of that wheel. So it's really simple. Just grab that node, hit my up arrow key to jump up one level, hold down my shift key to add to my selection, and then we're going to run a modify match transforms, match translate. And as soon as I do that, you can see that pivot point now jumped up. So I'm going to do this for all the wheels really quickly. Again, just holding down my shift key to add to the selection and then using my G key to repeat my last function inside of Maya. So up arrow key, shift, G, just takes a second to do this. All right, so with that done, the next thing I'm going to do is set up this door. And I'm not going to do the whole car because, we're quickly running out of time. I'm just going to kind of position these guys where I think the pivot point might be appropriate for that. So we'll just push that just into the inside edge of that door and kind of scooch that guy back a little bit. We can kind of do the same thing for the trunk. Grab that guy, translate it up, push it forward a bit to where that hinge might be. All right, that looks pretty good. And then the final thing that I want to do is add in a new bone for this back door. So we'll just jump over to our top view. I'll grab my joint tool. I'm just going to click and then hold down shift to draw a straight line, hit return to complete that function. And then we'll just kind of push that guy up a little bit, sort of where I think it should be, kind of push it back in ever so slightly. And what we want to do is we want to parent that into that cluster of bones. So we'll just hit the P key to do that. So with that done, we're going to go ahead and grab the context of this. So we'll just Control C that and paste it into the name of this guy so that it's not joint 51. And we'll call this rear door. L rear door. Perfect. So now that we've done that, the next thing that we need to do is export this skeleton out to become our new ID4 skeleton. So we'll grab our root, and it's very important that you grab the piece of geometry that has the skin cluster associated with it. For the skeleton to come across into Unreal correctly, it needs to have a piece of geometry bound to it. So that's just a little tiny helper. It's basically a little tiny cluster of one polygon essentially that's going to help us with that. So we'll do an export selection, and we'll save this out as an FBX file. Okay, so here we are back in Unreal. Let's just go ahead and undo that rotation and translation offset that we did to get the vehicle back kind of to where it should be. I'm going to go ahead and turn off the display of that Audi. We don't really need to see that anymore, so we can just turn that guy off. So we just have the ID4 in our scene now. So let's go ahead and jump up to our content folder. We'll go into car config, and we'll go into car and convertible top. And this is where the skeleton lives. So this was the original Audi skeleton. If we double click on this guy, and sometimes if they don't show up, you just need to say bones, display, all hierarchy. They might be set to only selected. So that is the Audi skeleton. So what we're going to do is we're going to import in, and you can just kind of pull this up here, a new skeleton. So we'll just do import. And if we go into ID4 here, we've got this guy, this B version that we just saved out. So when you import this in, you want to set it to be clear. You don't want to overwrite or modify a skeleton that already exists. So we're going to bring the skeleton mesh in. We're going to import that in. And you're going to want to make sure that you have, use T reference set to 0, and then also update skeleton reference. So make sure both of those are turned on and that's set to none. We'll do an import all. It's going to go through and bring that guy in, which is kind of cool. And now we've got this new skeleton, and you can see that we now have, obviously that trunk is in a different position, and we've got this new bone that we added in for this guy, which is pretty cool. All right, so with that done, let's go ahead and just save this guy out. All right, so let's jump up to where that control rig lives. So we'll go into car, blueprints, and double click on the Audi control rig. So the way this is set up is pretty straightforward. We've got in our rig hierarchy, we've got the Audi skeleton as well as a control system. These controls are handles that are basically going to drive those bones with forward kinematics. And that's all set up in this forward solve. So essentially you can see that it's going through and it's saying, Let's find the root control and have that drive the transform of the root bone. So it finds the root and the chassis, hooks those guys up, and then after the chassis, it runs through and does a for each loop to hook up the control rigs on all of the children. So it's a really simple forward solve for the majority of what's going on in the car. There are some things that are a little more complex for the front wheel turning, as well as the simulated rotation of the wheels. So these are also little rigs that are slightly more complex, and then obviously the trunk pistons are the most complex. It's worth noting that there are some nodes in here, like all the stuff on the right. This is kind of dirty laundry. It shouldn't have been included in the project. It's not being used, as well as these nodes on the top. So really, the majority of what we're looking at is really this kind of forward solve for the doors and the trunk and all the stuff like that. And then there's a setup script that we'll talk a bit about more in just a second. So what we want to do is we want to get a control rig that's going to drive the ID4 skeleton. So we're going to switch the skeleton from the Audi skeleton over to the ID4 skeleton. As soon as we do that, the bones disappear until I hit the compile button. As soon as I compile this, they're going to come back in, but they still look exactly the same as the Audi skeleton. So what we need to do is we actually just need to select one of the bones in the rig hierarchy and give it a little kick by going to refresh, skeleton mesh, and selecting the ID4 skeleton mesh. So as soon as I do that, you can see it's updated and it's given me this new bone here for the rear door. You'll notice that it's not selected, and that's because it doesn't have a control handle driving that. So you'll also notice that it didn't update the fixed position for the wheels that were out a little bit further and that kind of trunk thing that was a little bit taller. So to get these control handles to update the position, we need to rerun the setup. So by doing that, it's going to basically automatically snap those guys to the correct position. As soon as I wire in this setup execute into the setup event. So as soon as I did that, you can see the trunk's now up there, the wheels kind of got pushed out, which is really cool, and it does exactly what we needed and what we wanted. So we'll compile that guy. So the next thing that we need to do is we need to go ahead and create a control handle that's going to drive the position of that rear door. So we're going to literally just take the left door, which is this guy right here, and we're going to duplicate it. So we'll just hit Control W, and we're going to give this a new name, and we're going to match the name of that rear bone. So instead of Control 2, we're going to call this Control. And then instead of front, we're just going to switch this over to rear. And as soon as I hit return, you can see that it added in that and snapped to the correct position that new handle, that new control handle, which is exactly what you'd want. Now, the final thing that we're going to do is we're going to come down here to our forward solve, and we're going to tell it to propagate to the children bone. And by doing that, now when I rotate that handle that we just added, you can see that bone goes along for the ride. So with that done, we can go ahead and compile this, and we've basically set up the control rig. We added in the extra bone, and all the offsets are now correct for the ID4. So it's that simple to modify the way the skeletal structure works in a control rig. So the next thing that we want to do is get the ID4 hooked up to that custom control rig that we just set up. So this is easily done inside of the Audi blueprint. So we'll just double click on that to jump into it. And what we want to do is we want to make the doors and the trunk go along for the ride of these placeholders that already exist in the skeleton. So you can see this left front door is obviously aligned and ready to go. So what we're going to do is we're just going to go expand out our list of our geometry that lives on this underneath this ID4 root. And we're going to grab this left front door, and we're just going to make a simple relationship to those, a simple parenting operation. So we'll just grab that guy and we'll continue to scroll up here. And we're just going to drop it underneath that left front door placeholder. So with that done, you can see we've now got our left front door, and it's going to be underneath that point, and it's going to go along for the ride of that control rig's for the left front door. Pretty straightforward. So we're going to do the same thing for the tailgate. So we can just actually, to make this one go a little bit faster, we can search for tail, and we can just grab this tailgate right here and just drag and drop that underneath the trunk pivot point. And you can see that's now parented underneath that correctly. Looks pretty awesome. It's ready to go. So the final thing that we're going to want to do is we're going to want to get this rear door added in. And if you remember, we added this bone in. So if you look underneath the skeleton, there's no rear door null waiting to carry that rear door geometry along for the ride. So we need to add that functionality into this skeleton mesh. So how do you do that? Well, it's pretty straightforward. The first thing you're going to want to do is go into that skeleton mesh, and you're going to want to make sure that it's set to be that ID4 skeleton mesh that we imported in previously. So we'll just go ahead and we'll set that up. So with that done, the next thing that we're going to do is we're going to add in a new placeholder, a new static mesh component. So if you, with the skeleton mesh highlighted, go to Add Component and click on the static mesh, and we're going to add a new static mesh node into the hierarchy. We'll give this a name that's a little bit more meaningful. So we'll just call it L underscore, I think we'll call it rear door. So now that we've done that, the final thing that we need to do is just make this, hook the socket up to this. So go over to Socket in the Details panel, click on the search button, and if you just search for L, I think underscore rear door is going to come up. So we've done that. So as soon as I do that, you can see that that point now snapped exactly to where you'd expect it to be attached to that bone on the control rig. So we now have our placeholder that we can use to parent in the hierarchy of this left rear door. So let's just again drag this up to that placeholder and drop it on there. All right, so we'll just parent that in, and now you can see that our left rear door is underneath that, and everything's set up and ready to go. So the next thing that we need to do is start to add in the logic that's going to make this back door move. All right, so here we are inside of the event graph that has all the animation logic, and what we're going to do is basically match what's happening on these front doors onto the back door. So it's just a few nodes to create the animation state. So the first thing that we're going to do is jump into the animation variables, and we're just going to duplicate out. So it's made up of a few things: a boolean, a little branch, and then two different rotational values that get set. So the first thing that we're going to do is we're going to say is left door open, and we're going to duplicate that. So with that duplicate made, let's go ahead and just give this a name. So we'll just call it is left door open rear. And we can go ahead and drag that into our scene, and we're going to do a get on that guy. Then the next thing that we're going to do is we're going to drag that same is left door open rear and do a set. So we're going to pull off the get and do a not. So a not boolean to get the opposite effect of that. And with that done, we can go ahead and just sort of wire these guys up to sort of trigger that in there. The next thing that we want to do is grab this left door scale. This is a float that basically adjusts the speed of the animation. So again, we'll just highlight that, hit Control W to go ahead and duplicate it. We'll call it left door scale rear. Again, we can just drag that up, and we're going to go ahead and do a set on that guy, and we'll wire this in. And we're going to grab this animation speed variable and just duplicate it and pull it up here and sort of wire that in. So the next thing that we need to do is get this branch. So we'll just highlight that, duplicate it with Control W, and make these connections. So that's starting to look pretty good. So the final thing that we want to do is go ahead and set the rotational values to the two different states, the open and the closed state for the door. So we're going to grab this left door rotator, again, hit Control W to duplicate that. We'll call it left door rotator rear. And we can go ahead and just drag that out, and we're going to basically do a set. So we can expand this out, split that guy so that it's 0, 0, 0 for the false state. And then we can Control W that to go ahead and grab the true state, and we're going to set this to a value of 45. So the next thing that we want to do is, now that we've got our little logic that's going to basically set our two different rotational values, we want that to drive the control rig that's going to carry those static meshes along. And that's done in a slightly different area. So if we kind of pan across here over to the side, you can see there is this Anim car parts section. And this is doing the pre-forward solve. So you can see that this is constantly running, and it's grabbing the control rig, so the left front door control. So we're going to take this and we're going to duplicate it. And what we want to do with this is make this drive that left rear door. So remember when we created that in the control rig, so it was called left REAR door.
So we'll do that. And then the final thing we need to do is hook up those same variables that we just made. So we'll grab our rotator and we'll do a get on that guy and put that into the target. We're going to grab the scale and we'll do, again, do a get, put that into, scale. And then the final one that we want to grab is the, is it open? So we'll grab that and we'll say get on that guy and wire that in. So now if we just put this into the path so that they execute as it kind of flows through, we should be set with that. So the final thing that we need to do now is go ahead and have the execution of this get triggered. You can see the trigger down here is being driven by this switch. So we need to add a new enumerator into this switch for the rear door. So that's easily done by jumping back out into the content browser, going down into car, and let's go back in here to shared, and go into blueprints. And here you can see the car animation enumerator. So we're going to add a new enumerator in, and we'll just call it door rear. We'll go ahead and we'll save this out. Now, the other thing that we need to do is we also need to hook up the audio event. There's actually some dependencies between these. So sometimes if the audio event hasn't been added to the trigger effect, it will actually not work. So let's just make sure that we go into the car audio data also and create a new channel for that. For row 6, we're going to have it trigger out rear door, and then we're going to give it the door open cue. So we'll say the open sound, and then we're going to give it the door exit close sound. So we can save that out. We can save that. We'll jump back in here. Let's bring that Audi back up here and expand that out. And we'll just grab this rear door and we'll bring it up here and kind of go over into this guy. Wire that in, double click on this just to add a little node in there just to kind of tidy that up. So this is all looking like we've got it set properly. Let's go ahead and let's compile this and see if it actually works or if we get a warning or an error. So we'll click the compile button. So we got a little warning that popped up here, and this happens sometimes when you duplicate these rotator attributes, these rotator variables. Sometimes when you duplicate them, for some reason, they just don't work out. So if you just give this a new name, we'll just call it door 2, and then hit recompile on this, you'll see that it's going to clear that warning out. The logic's all fine, everything's good, but sometimes when you do duplicate those, you got to give them a little kick to kind of clean them up. So, and if you wanted to, you could actually go back and change that name back to whatever you'd want after you've given it that kind of that kick to refresh it. So just a little tip there. So with that done, let's go ahead and jump out to the editor, and let's hit our G key to display everything. So you can see that we've already got a focus point right here. That was done for the driver door. We want to add in another focus point for that rear door, and that actually lives in this same shared blueprints folder. So we're going to drag out the BP focus point, and I'm just going to drop it on the door of the car there, and then we can kind of zoom in on that guy. And the arrow you want to have facing out sort of toward the camera, something sort of like that. The final step is going to be to specify what animation this focus point wants to drive. So we're going to have it drive door rear. And I think with any luck, this is going to go ahead and work. Let's hit play and see what happens. All right, so there's the ID4. Animation's looking good. We're flying in. You can see the pop-up of our little focus points. It sort of happens right there. And if we click on the first door, it opens up. It does what you'd expect. We can close that guy back down. Let's give this guy a shot. So there's the back door that we hooked up with that extended control rig. And then, of course, we've also got the ability to open up the trunk, again, based on the modification that we made to that control rig. So that's the basics of how you can go ahead and set up the control rig to work with the ID4. So we're going to finish off by checking out how we can go ahead and start to wire in some of these paint color swatches. Right now, none of that stuff is hooked up, and I'll walk you through the process of getting that set up on the ID4. It's really pretty straightforward. So to change the color of the vehicle is actually quite simple because it's all set up using the variant manager. So let's check out how to do it. If we jump up to the shared directory and bring up the car variant, you can see the variant manager's checking out and doing a few things. It's changing the car paint on the Audi as well as some of the options like the wheels and the different trim levels. So what we want to do is we want to capture the car paint properties for the ID4. You'll notice that the actors have already been populated into the car paint variants. And for the Audi, we're managing a variety of static meshes with their material assignment. So it's quite a bit of static meshes inside of here. To make it a bit simpler on the ID4, what I've done is in the ID4, I've added in a custom variable that gives me one slot that's going to assign the material to multiple static meshes. So what we want to do is we want to add that car paint variable into the properties that the variant manager is watching and keeping track of. So that's simply done by clicking the plus button next to the properties with all of the actors selected. So we're going to bring up the list of properties that we could capture and tell it to start managing car paint. So we'll hit select on that. And now all I have to do is go into each one of the colors. So we'll pick Tango Red. And if we kind of move this up here a little bit and just scroll that up, if we go down to the bottom of the list here, you can see we're now looking at the car paint. And all we need to do is browse to where that cherry paint is by clicking the browse button. And you can see it kind of takes us right to that directory. And what we're going to do is we're going to map this cherry paint into the car paint attribute by clicking the arrow. So as soon as we do that, you can see the names change. To register that change in the variant manager, all you have to do is double click on the swatch. So now the car has been changed to the red car paint. Pretty straightforward. So we're going to do the same thing for the black. Let's go ahead and just grab that Audi. We'll go and we'll browse to the black car paint, select that guy. Come over here and click the map button, that little arrow, and then double click on the variant to go ahead and set that. So now we've got a red ID4 and a black ID4. So let's say we wanted to add in another swatch into the variant manager. It's actually super simple to do. All you have to do is right click on top of the variant that's in there and say duplicate. Now, if we scroll down to the bottom of the list, you can see that we have another black. So we're going to change the name of that to yellow. We'll go in here and we'll click on the actor. We'll grab this car paint and we're just going to assign to that the ID4 yellow car paint. And again, double click on the swatch to go ahead and set that color. Now to make this look a little bit better, I'm just gonna kind of fly in here, get really close to that, right click on top of that and say set from viewport so that we have a nice little swatch for that guy. So with that done, we can now close this down and let's play it back and see what we have. So we'll start up the configurator in runtime. We'll fly up onto the ID4. You'll notice that it takes the red variant. It's always going to take the first variant in the list. If you wanted to change that, just reorder the color swatches. As we fly around this, obviously all the other stuff that we hooked up is still there and still doing its cool stuff. And if we go to the paint swatches, we can now really simply change between the variants that we took the time to go through and set up for the ID4. So that is basically it for today. I'd like to thank you all for taking the time to watch the webinar. I hope you guys enjoyed it. We will be doing a few tips and tricks based off the product configurator, so make sure you stay tuned to our communication channels to find out when those tips and tricks are coming out. Cheers, everybody.